Hello students, this is your review for the Math 0306 Exam 1. And we have several sections to review. Remember that 2.1 and 3.1 linear equations and inequalities in one variable are considered repeat material from the level of math before this. 3.2 set operations and compound inequalities is considered new material at this level. 3.3 absolute value equations, also considered new material at this level. 4.1 through 4.4 considered repeat material from the level before, linear equations and inequalities in two variables. And 4.5 introduction to functions, again considered new material at this level. So let's go through some examples, beginning with 2.1 linear equations in one variable. I'll go rather quickly through these to conserve the video time, but remember you can stop and rewind these, pause, fast forward. You're in control of how quickly or slowly you need to go through these examples. So beginning with this equation, solve linear equations in one variable. Notice that this is a rather long equation, but it does only have one variable, x here, and x here. So our goal is to get the x by itself on one side, so this is how we proceed. First, to clear the parentheses, we need to distribute. Negative 5x, negative 15. Continue with plus 2x plus 5 is equal to 7x plus 9. Now on each side of the equation we should simplify if possible, so negative 5x plus 2x are like terms. Together they combine for negative 3x. Negative 15 plus 5 are like terms. Together they combine for negative 10. Continue to write the other side of the equation, which is already simplified. Now we want to eliminate the x's on one side, so subtracting 7x from both sides. If we subtract 7x on this side, the x term is eliminated, so subtract 7x on this side. Negative 7x minus 3x, now collect for negative 10x minus 10. And on the right, all we have left is positive 9. Okay. Our variable term, we want to eliminate the constant over here with the variable term, so we'll add 10 to both sides to eliminate negative 10. So adding 10 would eliminate the negative 10. We'd have to show addition of 10 on this side. Now we have negative 10x is equal to 9 plus 10 is 19. And we need to divide both sides by negative 10. And I'm out of room here, so let's write this out to the side. X is equal to negative 19 tenths. Now the negative could appear in the numerator out front or in the denominator. I chose to write it out front. 19 tenths is an improper fraction, but it is simplified, so it'd be fine to write your solution in that way. Let's look at another example. We need to again clear parentheses in this equation. Notice we only have one variable, x. Well, we need to clear the parentheses. So negative 5x, and then we'll distribute the positive 4 for plus 12x minus 8. And continue to write is equal to 4 minus 5x. Like terms on the left side, negative 5x plus 12x combine for positive 7x minus 8 is equal to 4 minus 5x. Alright, we need to eliminate the x terms on this side. So minus 5x, we could eliminate that with plus 5x. So if we add it here, it adds for 0. So we've eliminated the negative 5x. So a plus 5x on this side. Ready to collect like terms again. 5x plus 7x, 12x, minus 8 is equal to, all that's left here is a positive 4. I'd like to eliminate the negative 8 on this side, so we could add 8 to both sides. So we add 8 here and add 8 here. This gives us 12x is equal to 12. And we're ready to divide the variable term by 12. And we simplify 12 over 12 to 1. So our solution is x is equal to 1. Okay, let's work some more linear equations, solve some more linear equations here. These two examples have decimals in them. You can work with decimals in linear equations, but it's often a good idea just to go ahead and clear the decimals. So what's our routine for that? Well, we look at each term. How many terms do we have here? Well, this is a long term here because these two things are connected by multiply. So this is one term with a decimal in 2 places. This is another term which has a decimal number 2 places. And on the other side we just have one long term. These two things are connected by multiply, so one term with 2 decimal places. So everywhere we have decimals we need to clear 2 decimal places. So that would take multiplying by 100. Okay, so we multiply by 100 and negative 0.10 becomes negative 10. We'll multiply by the 46 later. Multiplying this term by 100 becomes 95x. Multiplying this term by 100 becomes 5. And we'll distribute to the x minus 20 later. Now let's go through and do our multiplying. This gives us negative 460 plus 95x is equal to, now we need to distribute here for 5x minus 100. Okay, we have x terms on both sides, so let's eliminate the x term on the right. That would take minus 5x, so let's minus 5x on the other side, and that would collect x terms on the left, negative 5x plus 95x for 90x minus 460 is equal to negative 100. Now we want the x term isolated, so we want to eliminate minus 460 with a plus 460, and that gives us 90x is equal to 360. We're ready to divide both sides by 90, and that gives us x is equal to 4. Let's work another one. Very similar. We have one term here with 2 decimal places. One very long term here. These are connected by multiply, so one term here with 1 decimal place, and on the other side just one term with no decimal places. So let's see, 2 places, 1 place we should multiply by 100 to clear the highest number of decimal places. So this term becomes negative 6x plus this term becomes not 1 but 10 to multiply into the parentheses later, and this term multiplied by 100 is 114,000. Alright, now let's go ahead and distribute here. We have negative 6x plus 10x plus 110,000 is equal to 114,000. We could simplify the left side by combining these two terms. They're like, for 4x plus 110,000 is equal to 114,000. Now we'd like to isolate the variable term, so let's eliminate the constant here, plus 110,000 with minus 110,000. Minus 110,000 gives us 4x is equal to 4,000. And now we can divide both sides by 4 for a solution of x is equal to 1,000. Now remember, it's a good idea to check your solution. Okay, you take the solution you find and replace all x's in the original with the number you find, and make sure that both sides produce the same result. That's checking your solution.